Okay, 2018 10b re-explained. Now there are two sentences that start off the question. One of them says when there's no immigration, the population increases at 2.5% per annum. And then if there is immigration, which is the next sentence, we need to include the amount that are lost in it. So that's what I'm thinking. The second bit, the second sentence even, tells you that people are emigrating and that factors in the amount that are lost. So this no longer applies. Now, that equation, like that, represents a population increase. With the population increasing but people being lost to immigration, that's the minus n there. And what they're saying is there's a population increase, but the population is decreasing by n people every unit time. So let's say that the unit of time there is the year. There's n number of people leaving the country per year, and that's what immigration is, number of people leaving per year. So this formula represents information with respect to immigration and not the simplified population increase model that we've already seen in this topic. Okay, let's have a look. So our conditions. We know that, or we're told that at the start there are p people in the population. X represents the number of people in the population. So there are p people in the population when the stopwatch is started. And what we're looking for in the first part is the time taken for the population to reach another value. So just x and t. So what I need to do is get a differential equation. And what I said to you is, first of all, you need something by dx dt on the left to start off. And then on the right, you need to make sure that you have no pluses or minuses. So basically, because we have a minus n here, it tells me I need to get a denominator, and then I can cross multiply very easily from this, because it's all cross multiplication from here. So when you cross multiply, you get that. If you integrate that, you get the natural log of x minus 40n, because n is a constant, x is the variable being integrated with respect to, and we have 1 over 40 by dt. That gives me that with those limits. Fill in the limits, and we'd end up with natural log of x minus 40n minus the natural log of p minus 40n on the left. When you subtract with logs, you divide with the numbers. That gives me that. And remember, the idea here is that we're looking for a formula for x. So I need to get rid of the natural log, in which case the thing inside the natural log remains, and the thing on the right hand side goes to a power. Now I can cross multiply by the p minus 40n, which I've done there, and I'm looking for x on its own, so bring that across, it becomes positive. And that's the answer there. So that's for part 1. Now, for part 2, we could use this, or we could use any of the previous 3 forms, depending on what we're looking for. Like if I'm looking for an x value here and I'm given a time, that's the one to use. If I'm looking for a time but given an x, that's the one to use. And you'll see that it's actually that one that I need to use. So n is 800, p is that, x is that, we're looking for t. If you use that formula, you're going to have to get the log of both sides. It doesn't make any sense redoing the work. The other formula, after you just subbed in your values or just integrated it, was that one. We're looking for t. All we have to do is multiply by the 40. And now all we have to do is sub in for x, n, and p. Sub those in, work them out in the calculator, roughly 5 years.